So welcome everyone to our 6th Computational AEC online gathering. My name is Andres Rivera Gonzalez. I am the product strategy leader for the computational design and automation team at engineering practice Aracon, and I'm going to be your host for tonight. So welcome everyone, nice to meet you. Now, as you can see, there's the chat available on the right-hand side. When feel free to please just drop comments whenever you want, or drop questions in for the presenters at any point during their presentations. On today's session, we are going to be having 3 presentations of around 20 minutes each, and after each presentation, we're going to be allowing some time for Q&A. So if you drop your questions in the chat, I'll make sure I unmute you guys after the presentation so you can talk directly to the presenter. Or if you prefer, I can ask the question for you and then have the presenter answer that question. At the very end of the session, we're going to be having a roundtable discussion. So please get your questions ready for everyone. Now, I'm just going to share my screen again. Can you see that? I'm assuming yes. So for those of you who don't know us, Computational AEC is a group of passionate and advocate, it's an advocate group of passionate people for design technologies within the AEC industry. There's a number of ways in which you can reach out to us if you're interested in presenting content or joining the group. We usually run around 4 or 5 sessions per year, and we're looking forward to continuing that cadence for 2020. So please reach out to us, get in touch. Any ideas are welcome, and we're always very keen to share what everyone's doing in this area, regardless of the discipline and regardless of where you're located. Special thank you to the event organizers, which is part of the group of Computational AEC, Venkatesh, Jos, and Giovanni. They've done a lot of work in the background to make this session happen, so thank you. And a special thank you as well to Swinburne University for sponsoring the event, and a very special thank you to Jane Clancy, who is running the software in the background and making sure that everything is nice and smooth, as you can all appreciate. So thank you very much, Jane. It's always really good to have you on board. Now, today I checked the Eventbrite site and I actually noticed that there's quite a few different countries represented in tonight's event. So I'm going to be very keen to see what the ideas and questions that people come up with, depending on the different backgrounds you might have. One of the perks about online events that I actually quite enjoy is the fact that anyone from anywhere in the world can just jump in and enjoy this from the comfort of wherever you might be at the moment. If you're in Melbourne, hopefully at home. Well, unfortunately at home, actually. If you're anywhere else, I hope you can have a little bit of space somewhere else. Tonight's event is going to be focusing on robotic fabrication. Now, for those of you who haven't been really involved in the area or don't quite know what robotic fabrication means, it can be a little bit confusing at times when it comes down to actually pinning down why is this useful for us if we're talking about the architecture, engineering, and construction industry. There's quite a few examples out there that are quite obvious in terms of their benefits, such as on the left, you can see the automotive industry using robots to automate their processes, or on the right-hand side, something like the Amazon warehouse that uses robots to drastically enhance and increase the efficiency of how they catalog and pack all the products. If you're familiar with a little bit more bespoke use cases of robotics, you can see something like what Grandmaster Color did back in Switzerland, which is a bricklaying robot, which back in, it might seem quite simple, but it was actually quite innovative when it got started. or something such as on the right-hand side, Alexander McQueen, spring 1999 runway, where he used a robotic arm to spray paint the dress and wowed the audience. So if you think about these use cases, a robotic arm is basically a tool that if you're able to program it, you can actually just use it for whatever you want. But on today's session in particular, we're going to be focusing on the uses of robotic fabrication within our industry. And I'm very happy that we have three very talented, very knowledgeable speakers in the area. We have Daniel Prohasky, and apologies if I mispronounce the names. As you may have noticed, I have a very thick Latin accent, so apologies in advance. We have Daniel Prohasky from Swinburne University and co-founder of Curvecrete. We have Dr. Dagmar Reinhardt, who is Associate Professor at the University of Sydney and Chair of the School of Architecture. And we have Alex Walzer from RMIT University in partnership with INCRC. So please join me on welcoming all of our speakers. Thank you very much for allowing your time and sharing your knowledge and expertise with everyone. So we're going to start the presentation with Dr. Dagmar Reinhardt. So she's quite a prominent speaker, and she has contributed a lot to the robotic fabrication field within the industry. She has written quite a few articles and has quite a few publications, has won several awards, and she leads the digital architecture research arm within the School of Architecture in the University of Sydney. So please join me on welcoming Dr. Dagmar. Whenever you're ready, I'll hand over to you.
Sorry, muted again. Thank you. Very super cool. I'm just going to share my slides. Okay, can you people see that?
Yes, perfect. We can see very clearly.
Yeah. Okay, thank you very much. So first of all, thank you for the invitation. Thanks to Horst, thanks Andres for the lovely introduction, and thanks to Jane for hosting. I'm particularly delighted simply because I think it's always great that we can sort of meet inside the industry, but also brainstorm a couple of the really pressing questions that we are faced with in terms of doing our research, in terms of developing industry collaborations and really bringing the field fast and forward. My talk today is loosely labeled Human-Robot Collaboration, Work Processes and Interfaces. It's basically a very long list of things that I have been doing since 2012, which really very much describes the fringes of research within the practice of architecture for the construction industries, within the practice of academia, by teaching students, by doing multidisciplinary collaborations, by working heavily with our fantastic team, DMAF at the University of Sydney, and by our great industry collaborators. And basically what I want to do today is to give you a very brief overview, but also as a word of caveat beforehand, you are getting me at a critical day, so I'm very happy to throw some questions around as well. We have introduced the Robotics Lab at the School of Architecture, Design and Planning at the University of Sydney in 2012, starting with a smaller KUKA and then successively and increasingly building it up, undertaking very many different research projects across the different strategies, subtractive, additive, formative, and interactive, so towards the possibility of human and robot collaboration. We also had the good opportunity to work with the Association for Robots in Architecture and to be able to host for them the very first Australian conference of this very famous series, Robotic Fabrication and Architecture Art and design. We did that together with Jane Berry and Rob Saunders and Marjorie Mela. You see here the top of the POPs heads of all the robot facilities, so primarily KUKA and ABB hopping here. We had as accompanying the conference were a series of workshops, which were really the heart of the 2016 conference itself. Collaborative teams between international universities such as Harvard and YAC, working with the University of Sydney, RMIT Melbourne, SciAC and UNSW, also based in Sydney. Monash University partnered up with ICD Stuttgart, Bond University partnered up with Schwarz, and then UTS worked with Michigan University and the school, UTS School of Architecture. So for people who are not entirely familiar with the field, if you go to the Robots in Architecture, Art and Design website, this has been going on as a biannual conference since 2012. There is a lot of publications out there, but what I find most fascinating is that the work processes are displayed in short movies that accompany the conference and which also can be found on the website. So just a bit in that context. We at the University of Sydney have been working across and slowly making our ways across different fabric possibilities, from subtractive cutting of a plaster mold and then continued clay deposition in terms of mold making towards different investigations into interlocking structural components. Here also with my colleagues Shayani Fernando and Simon Weir, here the stereoatomic wave jointed blocks, but also more, let's say, more happy or more sort of mundane applications in terms of punching clay, for example, in order to derive patterns, or stacking wood blobs, etc. So we've all been going through sort of these small investigations, talking about sort of the original capabilities of robots. But I think the point at this stage, and this is really 5 years after a more general introduction to industrial robotic arms being adopted by a number of different architecture schools, thus laying the foundation, is in which way do robots actually connect to the industry, and in which way can the use of advanced robotic system support Industry 4.0? And to that extent, I can really sort of reference back here to Olivier Scalabo's Next Manufacturing Evolution. That's already 2 years old, but it's really interesting to see how all these different segments and systems can particularly join into each other. Because, and here's one of the things that I really believe in with robots, is it's a direct and explicit transfer and connection from computational design to over structural simulation or other simulation methods towards an immediate and direct work into a fabrication realm in a much more immediate and intuitive, but also more customized or serialized way than any standard digital fabrication method would basically enable us to do. So what's the landscape that we're at the moment operating in? If we talk about robots as something that's not purely working within closed protocols, but that's something that's open-ended, that's collaborative, that's sort of on-site, that's working with in a very complex, temporal complex spatial and time continuum. So ETH have developed quite a lot in that regards, particularly in the context of the D Lab house at the ETH in Switzerland, here with the robotic fabrication of bespoke timber frame modules, which have been basically the robot introduces the precision and the human then goes in and does anything that the robot, due to its sort of still relatively restricted positioning, even within these sort of overall larger gantry systems, more flexibility that can be offered in that system. ETH has also then, of course, continued that further with the automatic path planning here with the welding. You see again here the human interaction proceeds through the hand that reaches into the two robot systems, and then finalizes basically the fabrication process. And we see here, this is all material from sort of basically around 2016, 2018, an extension of what has been really fantastic a decade ago with the research that Gramazio-Kohler has been doing is now being extrapolated, robotic bricklaying that Andres has been showing, which is now heavily implemented into industry, not even as a research, but as a execution of complex architectural projects, such as here Philip Johan's robotically laid brick facade in Shanghai from 2016. But I think some of the things that become much more interesting are then how actually robots can not substitute human labor, or in terms of precision and control, and in terms of affordability and economic cost, etc. But how do robots bring something to the equation that could potentially not have been foreseen? And that's, to me, that's starting here with the adaptive robotic carving training methods for the integration of material performances, which basically means that a carpenter does a procedural pass across the wood by carving into a particular pattern that follows the grain of this discrete texture, and the pressure that's measured can be exerted by the robot in the same manner. So we're talking about completely different things here, where very much in depth the process is analyzed, is documented, and is then implemented for a very sensitive robot that can execute tactility and a manual capability, mimicking what the carpenter would have been doing so far. And then, of course, we do have robots that are no industrial arms, and that very much expand the possibility for on-site robotics. That there's still a lot of work that needs to be done here in that regard. But so Jaak have made a good dent into that theme with the Claybot, and then the Fiberbots from Neri Oxman, and also interactive studies, which very much happen in the human-robot interaction scene, from which we could learn much more. But so what's really interesting to me is to not to understand the robotic work conceptualization in terms of how can we automate, because we've all been there, but to take each of these discrete problems, the 6-axis standard robot system, the toolpath, the controlled workspace, the machine constraints, the producible dimensions, and the whole problem of the end effector, so the robot as a 6-axis workshop, basically. How can we take all of these questions and really use them as sort of departure points for our robotic projects? The other possibility that I still do see is how do we bridge the divide between understanding robots that are extremely sensitive and the replacement of humans, such as humanoids, which are now being investigated in the arena of social robots, or as replacements or extensions, so in a sense robotic counterparts of our human faculties. So where are we within sort of the architecture and engineering community and construction industry if the field of human interaction is really pressing forward with that matter? Okay, now we're beginning into the case studies, 3 of them here, and I'll just walk you very briefly through. So these are sorted according to the times where we have developed them. Due to my particular interest in how does the machine actually relate to any benefit that we would have in architecture through the arena of robotic fabrication, the starting point for us was here the project that deals with the idea of sound and robotic fabrication. So the very first project that we see here looks at TriVoc, how to carve out a larger robotic space that then sounds in a particular manner. The other one is a microacoustic pattern that again plays back the idea of a human voice in a particular manner. So how, in a way, the project asks how can robotic fabrication be used in order to specify and sharpen architectural surfaces, and so that they would either increase the sound volume or diminish or create discrete spaces etc. The very first project was set up as a sort of tri-dimensional space. So if you see these sort of different curvatures here from ellipsoids that we have designed in MATLAB, and when you sing into any one of these ellipsoids, a different tone arises. If three speakers or singers stand in the middle and sing into those curvatures, a harmonic chord is arising through the sound that's been impacted by the surface and played back. We went through a couple of different tests in terms of the second project here, which is basically then looking at the different patterns and different pattern techniques. You see here that basically as a principle, the sound is being reflected back by the acoustic by these acoustic surfaces depending on the angle. It works a bit like light. We expanded that towards a sort of larger surface. That was the idea of an acoustic chandelier that could potentially be sold. But really the meat of the project dealt with the idea, can this be tested and can this be improved? And we very quickly realized that the hexagonal patterns, which we thought had more possibilities, were actually performing less good than the flower pattern, which I had just basically thrown into the equation because I liked the properties of that. But so again, robotic fabrication and based on the simulation or continued testing makes also fabrication or this sort of dimensional fabrication that takes into account time or other invisible forces gives a good opportunity here. The second thing that we learned is that we can make, and I had already named that before, we have a possibility to really look at sort of the whole span, starting from base geometry, going through structural analysis, going through acoustic analysis, going straight to robotic fabrication, and then of course not doing that just in a linear, but to go back in an iterative or media rotation aspect across all the steps in order to shortcut. So a direct linkage between the computational design data and the robotic fabrication output. What we also learned is that in principle, why can't I move over to the next slide? Oh, this is interesting. I can't move over the next slide. Sorry.
We can see the one with the. I think it's just text on the screen. Oh, now we can see one with the film prototypes.
Yeah, do you see the one with result workflows and collaboration? Ah, here, there it is. Okay. So basically what we understood is that in the same way as Grasshopper gives us a sort of overview of all the different of the DNA of a project and the sort of the geometric data or the formation data, in the same way robotic fabrication gives us access to different opportunities within the design realm. So from the same DNA code, you can actually fabricate quite a lot of different data. We use that in order to, you see here, very, very simple, very mundane system, just a hot wire cutting, with which you can actually fabricate quite a lot of different patterns themselves. So we took the acoustic pattern and gave that to a number of students who came up with these different tectonic plates, 36, that we basically tested. Again, this which we then fabricated and went moved through a reverberant room in order to understand the capacity, the acoustic capacity in terms of absorption or reflection of these panels, and that allowed us to actually establish form archive. That's not only a form archive in itself in terms of aesthetics, but also in terms of acoustic performance relative to the end effector, which in this case is just a very simple tool of the wireframe in relationship to the performance as had been tested across the geometries. So this is why I like the multidisciplinary collaborations, because that's been thanks stencil again over to our acoustic partners. The other thing that I find interesting in the arena of patterns is, and that's research that's ongoing, is that the possibility of pattern not only something that can be acoustically effective, but also something that offers a completely different range of tactility. So this is a project we have in the same range of the pattern category that's available through robotic carving. developed with the School of Blind and Partially Sighted, EBOS in Copenhagen, and my time at Aarhus School of Architecture. And so this is a hybrid surface that enables people to understand to understand the braille pattern that's inside that only blind people can read or partially sighted people can read, and then a larger visual domain of or patterns that are accessible in a very different manner to a sighted audience. Case study number 2 is a robotic weaving for our industry partner in VN in Sydney, where we basically looked at what can we do with a normal existing office ceiling structure that is aesthetically not very pleasing, but also doesn't allow the possibility of a data distribution, hence the idea of producing data booms that would bring electric cables and Wi-Fi cables down in the vicinity of 7 seats, 3 tables sitting underneath those. This project really deals with the idea of robotic carbon fiber weaving, where we went through a number of case studies here, a one-on-one pilot study that trials different series of different end effectors, mimicking of the deposition series, tracking around tooth system here in a concentric ring. We very fast updated then that system. So what you see here is a commercially packed carbon fiber winder with the resin bars and the curing. You see the that's updated, which basically then we tested a couple of different iterations, weaving between 3 different ceiling parts onto this ring, on which then there's a distributor of the electric cable and Wi-Fi. It was interesting to see how this curvature arises through the process of deposition of the carbon fiber, allowing attention, the compression within the system. Again here, 25 kilos that sit even on a sort of very generic distribution as has been sitting here. We developed 4 different prototypes inside and on-site, the ceiling of the BVN office that follow different project criteria. So the most simple and symmetric alignment, the most obstacles in the path, the longest distance between the robot itself. And what became all quite interesting was setting up a process so that a number of unskilled laborers could contribute to that. So of course there were robotic technician in the production process on the site, but there were all office workers that participated within the overall protocol. So in a way you could say that the output is not simply the object itself, but the process, and also inhabiting the process by people who were unfamiliar with the sort of basic systems themselves. We were then able, that's the final product, and we were able to produce that in 4 different phases of 16 different robot positions, while the office was ongoing around basically this robotic on-site construction. A small moment of pride here, we were then also able to provide some knowledge transferred to DI fabrication network for the 4th Istanbul Design Biennale in 2019, with whom we shared the generic robotic setup, the jigs, and also the framework in which we have been weaving. And now, last but not least, that's basically the last project that at the moment that we've been working on, and this is the idea of robotic collaboration or cobots, so collaborative robotics for subject matter experts. That's a grant that we've been doing together with Lancome, UNSW, New Sydney and Western Sydney, that really looks at the benefits that each of the 2 workers in a way bring to the equation. So the human has the dexterity and a good problem-solving skills, but has fatigue, where the robot has strength and no fatigue, but really also doesn't have any intelligence. If you bring robots to site, they are, of course, restricted in terms of size and payload. And some of them have low speed. The level of risk needs to be checked, and there's limited applications in terms of dealing with them. But luckily enough, there's a couple of collaborative robot systems that are around at the moment, which brings us out of this safety monitored stop in the robot cell towards on-site handling for multiplicity of different robot work, so screwing, loading, handling, assembly, gluing, and inspection. So we took that as a departure point to particularly look at different traits that appear on a simple residential building project, as appears in the domain of Landcom. We did an overview of different tasks that would controllable, would be accessible, and would be achievable, and then focus on carpentry trade with the idea of a stud frame wall and the different end points that would be necessary in order to bring this forward. So again, what's really important here is it's the work output is not so much the product itself, but it's really very much the definition of the work process and which parts then the robots could basically take over. So we tested it in the lab, we tested it on site, we broke it down into different component parts, bracing, carrying, gluing, cutting, nailing, etc., and checked out in which way a smaller industrial robot arm really could be on the side. As said, that's still ongoing. So movability of even of a smaller robot arm depends on the mobility of the system itself. As we speak, this is being coupled with monitoring of the system by motion capture, and compared with that, we are also looking at systems that directly translate human gesture within this workflow. That's a robotic gesture, and to that extent, happy how to Grill and the other people from Photogram, which I think have completely introduced this game changer by adopting the HoloLens for construction work processes. So the moment when this is coupled with the robot, we're really going into a very close relationship between sort of collaborative robotics and the human worker, that by that introduction of that vision system, it's also being implemented into that work process. So I think we are looking at a real game changer for the whole industry, and we're just at the tip of the iceberg in bringing all these different facets together. So point number one, the possibility of a graphical or haptic programming that defines the robotic toolpath rather than the product itself. That could change in thinking for the architects. Looking very closely at the operator envelopes in relationship to the human co-worker, implementation of systems that prevent collision, the introduction of interfaces and vision feedback for instant assessment of data, interfaces that can be continuously renewed. That also means that a human can set markers or drawings can be made and being fed back into the overall system. The possibility of multiple tasks that are shared between the robot system and the human system. And then forecast to the future, of course, the factory on the fly, visual drawn data and robot interfaces, and understanding robots as a work environment or shared resource as something that might be as ubiquitous as the 3D printers that we now have seen pop out in all the libraries. And with that, I would like to say thank you for listening, and hand over back to Andres. Thank you.
Thank you, Dagmar. Wow, I'm just really impressed because you've worked on such a broad range of things, and I think I have so many questions. I'm going to save quite a few of them for the roundtable at the end. But just looking at the presentation that you just did, and I think everyone will agree, it was incredible to start with this and see such broad range of things that actually are happening within the industry. I think I do have one question to begin with, and it's a bit of a high-level one, but I would like to get your thoughts. You've been involved on the robots in architecture cohort since the beginning of it, and you've run so many initiatives since such a long time now. There has been, at least I feel, a much greater adoption of this technology within the industry. And just looking back at what you presented, you had some patterning techniques, you had some geometry building exercises, and you've had something that starts to become nuanced enough to be able to I guess, to coexist with humans, such as the carpentry examples that you showed. Out of all of these experiences that you've had, which one do you think would be the one that's going to have the biggest impact on the industry moving forward? Or which one do you expect is going to have the biggest adoption at a commercial scale?
I think the biggest, I mean, to be quite frank, I think the biggest adoption at the commercial scale will always be sort of the quick and simple solution. So something like a factory on the fly, which would still gives us at this present stage, because the industry needs outputs and it needs return for investment. So whenever you give an opportunity in order to set up a system, that system will necessarily be closed unless we train up industry to inhabit that system and to bring it forward. So I think the question is really not so much can we bring robots into the industry, but can we bring computational designers and robotic technicians into the industry, because we need machine operators. And I think that's actually where it becomes really interesting, because this is the question: what do we train up? Do we train up architects that are then still drawing with pen and paper, or in that case then a Grasshopper in Maya, or go through simulation or BIM or Revit or whatever you want? So is that the point? But that doesn't bring us the workspace. Or do we go towards a specialization where we actually train up people that feel comfortable both in the field next to the board and diving deeply into the area?
Yeah, no, that's a very interesting point. I think, I mean, you're obviously being involved in the University of Sydney very heavily at the forefront of what education in architecture looks like in this point in time. Have you noticed that there's a greater intake from students, a much greater interest in this kind of technology at the moment, and do you think that will progress even further on the next couple of years?
Absolutely, absolutely, because we are getting tech-savvy people. So, I mean, people who've been sort of playing with any of those technologies right from the start won't find computational environments very different. But then it just becomes a moment of exposing people to machinery. And in fact, we have a lot of undergraduate students which absolutely embrace the idea of robotic fabrication. So that's a completely different generation that's being sort of going out there. And so this is why I find it so interesting to collaborate with industry partners and to bring them onto the occasion, because there's a real life application, there's real life demand and connection. So we don't keep them in the ivory tower and then let them graduate, but we continuously expose them by means of new processes, methods, and technologies towards the field in which they can work later. And in fact, I mean, so if I was going to study again architecture, I would probably just throw a couple of bucks together, a couple of thousand bucks together, with a couple of people, invest in a robot, and just sort of start making not an office, but making like an operation management application consultant. And that's already out there. I think we need to, that's a big chance that we do have. And I think people can thrive in that. It's a completely different world.
Yes, no, completely agree. And I mean, like, I kind of, I agree what you said now. Even, I didn't graduate that long ago. And even then, I remember when I was back at university, I was still one of the few strange people who were doing things with the robots. And, it's really crazy how things have changed so quickly in just a few years. And I'm really excited about the possibilities of everything. Thank you very much for your presentation. I think, as I said, it was a great starting point for this session. I think everyone's like, "Whoa, this is what's possible," and that's exactly what we were after. So thank you very much. And we'll be jumping onto the next presentation now, but just to remember everyone, and for everyone that just joined, please feel free to drop your questions on the chat at any time, and I will make sure to direct them to the presenters at any time, or I can just unmute you so you can ask the questions directly yourself. And at the end of the session, we're going to have a round table with the three presenters. So please write some notes and get ready for an interesting discussion. Thank you very much, Dagmar. So our next presenter today is Daniel Prohasky. Daniel, as I said on the introduction before, is a lecturer at Swinburne University on architectural engineering, and he is the founder of a very interesting joint venture called Curvecrete, which we will be hearing, I'm assuming, about in a little bit. So please join me on welcoming Daniel. And Daniel, over to you.
Thank you, Andres. It's great to be here, and thank you everyone for organizing this great event. Thanks, Ben, for inviting me. And it's great to see some familiar faces in the audience as well. Now, can everyone, yeah, my screen has been shared.
Yeah, we can see your screen.
Let's go full screen. Eventually, there we go. All right. Okay. Yeah. So what a fantastic way to start off the evening with a really extensive overview of the state of the art in academia in terms of robotic fabrication. It's so diverse, but it's very complex, and yeah, I'd like to sort of give you a bit of an insight into the journey that I've been on over the last 3 or 4 years, trying to bridge that gap between academia and industry through this journey from the research lab to commercialization, or academia to innovation. And it's a lot like walking a tightrope. It's a balancing act. You know, and myself, I'm an architectural engineer, so I have you know, architecture on one side, engineering on the other. Always sort of flipping between the two, but trying to keep balance as best I can. And yeah, so I've been involved in quite a lot of diverse projects, especially through yeah, thanks, Andres. Yeah, so I think we're in a familiar space here. Everyone's trying to you know, navigate this really complex space, especially through computational design. But now we've got you know, robotics systems that we can play with and interface with much more easily as architects. But the engineers, they are very, it's very difficult for them to understand what the architects are trying to do, because engineers are trying to reduce the risk all the time. So yeah, we have to help the engineers to say, actually, we've got a simpler way to do things by using advanced manufacturing processes. But a lot of those examples, they all use like a really complex, like Kuka or ABB arm with 7 axes, sometimes 6 or 7, and they're very nonlinear systems. They're very difficult to control. So you know, jumping the gun in the details here, but just reflecting on the previous presentation, you know, what if we could simplify that by actually making fit-for-purpose robotics that are specific for the construction industry, and provide a lot more value for the different stakeholders in the building and construction industry, and therefore can translate this sort of robotic technology much more seamlessly into the building and construction industry by being very commercially relevant. So what I'd like to try and answer, this is the journey that I'm going on, and haven't completed it yet, but you know, how might we implement new technologies and knowledge in industry to enable resourceful design now? So and you know, in this context of robotics or advanced manufacturing. So over the last must be 3.5 years or so, I've been involved in a project that was called Parametric Adjustable Mold. It started at University of Melbourne, and now we've gone through an extensive journey towards commercial endeavor, which is called Curvecrete. And I'll give you a bit more of an insight into what Curvecrete is. We've been involved with, basically it's a startup that has been involved with accelerator programs in order to find the commercial relevance for what we're working on. So you can visit our website and find out more and get in touch with us at any point if you're interested. So it's an extensive team. It really does take a village to raise a robotic child, and it goes across institutions. It all started with Paul Lowe, the University of Melbourne, and his esteemed colleagues there. And I came on board in late 2016, early 2017, I think, for the research project. And then Warren came on board for the commercial aspects, and we have been engaging with different design consultants along the way as well. And yeah, so the team is very important, of course, to try and raise this robotic child, but I'll get into what it is that we're actually doing. So it all starts with a problem, and yeah, all about the overuse of concrete, basically. So these are the concrete jungles that we live in, and to construct these concrete jungles, we use a lot of single-use formwork, which contributes to one of Australia's major waste streams, 40% of construction and deconstruction. Concrete itself contributes to almost 8% of all global CO2 emissions, which is terrible. So, you know, how can we build a future where we reduce waste through beautiful design? And yeah, so in terms of the, so it's a dual approach that we're taking at Curvecrete. One is looking at the material itself. So we currently have 400 megatons of waste fly ash that we can use for geopolymer low carbon cements that are of equivalent strength to standard Portland cement. And the other thing that we're tackling is the formwork itself that forms that's required to form the concrete shapes. And here you can see that the Sana Rolex Learning Center wasting quite a lot of timber to form this structure. So what we're trying to do is use more of the waste fly ash rather than standard Portland cement, and use less formwork. And we can achieve that through using a robotic formwork. So it's adaptive formwork that changes shape to create beautifully curved concrete panels. And I think I've got a video here somewhere, but for some reason it's missing. Should have been earlier in the presentation. I'm just going to do a quick flip, and then you can actually see what I'm talking about. I wonder if you can hear that. I can. It's not exactly top secret, but That was a robotic formwork doing its thing. So it's a ruled surface geometry, and basically the process is that you pour the geopolymer low carbon cement, which is about 80% less carbon emitting, onto the mechanical mold. You deform the mold and then remove curvy panels, make curvy things. This technology is valuable to 5 key stakeholders in the building construction industry. For property developers, they can differentiate themselves from other developers that aren't innovating, aren't creating beautifully curved, low carbon, exciting architecture. The architects, it's a design enabler for them. More often than not, it's cost prohibitive for architects to create beautifully curved things. It tends to get lost in the value management process in a project. The engineers, curvy things are very, very complex traditionally if they're all free form, but using ruled surfaces, which our method does, simplifies this quite drastically, and we're creating streamlined design processes that engineers can then feed into to sign off on these types of curved structures. For the builders, simply just more cost effective. This one is obviously very variable because there are very cost effective techniques being used in China that get imported into Australia, but there is a push from the builders here locally to use local products because of quality control, because of the current climate with COVID, and the complexities around shipping at this time during COVID and during the current new tariffs that China are experiencing. And then the precast concreters, with a different business model to the one that I'm alluding to, and the first four. The first four are where we actually supply beautifully curved panels, and then this last one here for the precast concreters. When we start supplying machines to precasters globally, that will open up those precast concreters to new markets that they couldn't access before. It's a very, very big industry, as we all know. It's very complex, but it's also the second least innovative industry in the world, only second to horse racing. And the reasons for that is a very, very risk-averse industry for very good reason. We have to make sure that we create safe structures. However, this does prevent a lot of innovation from happening. So we covered this off. I'm assuming most of the audience knows what a ruled surface is, but it's a form of hyperbolic paraboloid that can be described with straight lines. That's what makes it quite simple to form these doubly curved shapes. It's a negative curvature or anticlastic curvature. The great thing about this geometry is that it's one of the most structurally efficient geometries that you can use, and especially with concrete, because wherever it's loaded, if it's a pressure, so say if you put it on a facade, always some of the panel will always be experiencing compression. So if it's pressured from the top side, I'm not sure if you can see my mouse, but I'll try and gesture with that. If it's pressured on that top face there, the arching action will happen on the diagonal, and vice versa, if there's a suction pressure or something. It's been used by quite a number of architects in the past, we did a few early explorations into the actual strength of these kinds of curvatures. We've done quite a lot more since this, but say for instance, if you had a surface load of 3 kPa, which is basically equivalent to a live load for a traditional office building, or a very, very strong wind, the flat panel deflects more than 10 times the amount of a very slightly curved panel. This example has a curvature of about 20 meters radius or so, which is very subtle, and it increases that stiffness significantly. That's because of that arching action and the span to depth ratio that's increased. The stress relationship, that's around about a factor of 4, thereabouts, 3 or 4, reduction in the distribution of stress, which is quite helpful for those connections where you've got high stress points. So when you're designing with this method as architects, you can take a free-form surface and panelize it with quadrilateral panels. They don't necessarily have to be all the same edge length. They can be different edge lengths and different shapes. But when you're panelizing something of this nature, there's always a twist involved with those quadrilaterals, and that's what our machine is able to accommodate for with this sort of pseudo folding action that our machine creates. So we've demonstrated this with the University of Melbourne team, with Paul Lowe and David Leggett and myself. This is our concrete example that's on display in Arup's office. It was on display for Melbourne Design Week in 2019, very early on. It actually was on display for Melbourne Design Week 2020, which lasted about 3 days, and then we all got locked up in our homes. But some lucky people got to see it, but soon it will have another home very soon. So conscious of time, I'm not sure how much time I've got left, but I want to show some pretty images and where we're going, and maybe a bit of a stumble along the way as well. So I'll try and cover this bit quite quickly. The challenge that we've got with this method is that we can actually apply it to so many different things. So we have to try and find a commercial focus. And the first thing that we sort of dabbled with, because we had this challenge of very long sales cycles in the building construction industry, we have to wait 12 to 18 months and do design consultancy work to work towards actually getting something built. It's a very difficult thing to do. So we thought we would design an industrial design product for a competition for the National Gallery Victoria, where we were a finalist and we came second. And it was all about looking at using local sources of fly ash from the Latrobe Valley region, from the coal power plants Loy Yang, Hazelwood, and Yallourn, that create some really beautiful hues of concrete for us, of low carbon concrete. And yeah, so we have these three versions of chair that we call the Superleggera, which means super light in Italian. Is a collaboration with an Italian industrial designer, Marco Scher. And yeah, here you see those three, and the hazel one is smoking like a ghost because that power plant has just been shut down, which is fantastic. But it's left behind a hell of a lot of fly ash that we could use for a cement replacement. And it's just sitting there. Yeah, so we use a lot of different digital design tools. Sorry, I should sum up with the chairs. We still haven't made one. we do want to make one, and it'd be great to know if anyone's interested in having a concrete chair. But yeah, we haven't actually made one yet, so it'd be great to pick that project back up. Yeah, so we use a bunch of parametric design tools. I'm sure you're quite aware of those in the architectural space. Some of you may not be as aware with the sort of gaming software that we use for our renders and that sort of thing. So we use Unreal Engine and Assumptions Painter to actually animate and render out our architectural designs. And concepts that we attempt to make. So, yeah, over the last 18 months to 24 months, I've been developing some integrated workflows to help designers work with our method and to give them some inspiration about what we could build, and done case studies on the stadium scale. Looking at how big we can go, but also looking at what's next. We create these beautifully elegant structures that we can reduce waste, through beautiful design, and be enabled through advanced manufacturing to do that using very simple, elegant robotic techniques. And making them very commercially relevant. So it's very easy for easier for the construction industry to uptake that technology. Yeah, so I'll finish up there, I think. Thank you.
Thank you very much, Daniel, for that presentation. I think one of the things that I enjoy the most about the work that you do is that you identified a problem on the industry, and you've been kind of like end to end really trying to make it work, and you've reached a point now where I think it's at a mature stage where you can actually now start producing chairs for robotic fab labs and things of the like.
Yeah, I think I missed. I want to show you actually some of the more architectural scale stuff. I kind of breezed over that, so I might just jump back in, see if we can share this. Yeah, okay, it should be coming up. Yeah, so towards our first project, right? So we did have a project, a couple of meeting pods for a co-working space, and unfortunately, COVID, isn't very the current climate isn't very suited to co-working spaces. So this is like a sort of interior design scale, I guess, still industrial design scale. But what we have been doing is working with one of the tier 1 property developers, Mervac, to implement our techniques on some of their projects. And I'll just give you a little snippet of a feasibility study that we did. I mean, this is a climbing wall basically there was an existing project that they actually built. We didn't actually get on that job, but we did a comparison directly with what they had done, and it seemed that we were within their cost, time, and quality metrics, and we also have on this project, if we had done it, we would have saved. I can't remember the exact numbers, but it's around about 80 to 90% of the CO2 that was used on the previous concept that actually got built. So it is a viable solution for the architectural scale, and we're currently bidding on commercial facades for high-rise building, and like I said, working with Mervac to do a few other projects as well, for the sort of urban artwork, landscape architecture sort of installations.
Yeah, no, it's fascinating. I think it has so much potential to go forward in that sense, and it's really funny because with these kind of projects, like you see the physical prototype, and someone could just walk past and be like, "Oh, yeah, well, it's like concrete panels." But there's so much work and so much, like, such incredible thought behind everything, and I think one of the questions, if there aren't any from the audience, I think one of the questions that I would ask you, you've been through these really extensive thinking process as to how you can actually bring these onto a commercially viable solution. Mm-hmm. What do you think, if you were to be speaking to someone who's just about to get started on a similar adventure or journey such as yours, what has been the biggest challenge, or what has been the biggest, I guess, your biggest learning that you could, pass on a little bit of knowledge to those people?
Well, I can't pinpoint the biggest one. I'd have to sort of reduce it in its complexity, because I guess the number one thing that you would hear, I guess, is for these things to be a success is just persistence. So it's a mental attitude that is the key thing that makes any of this happen. It's just persistence. So if you're ever wanting to change the way things are done, then the attitude has to be a persistent one, but you have to be aiming for something that is ambitious enough and far enough into the future that you can then, no matter which way you turn through the journey, you can still point to that and persist towards it. So for me, it took me a long time actually to try and define that vision and what it was, but it all sort of stemmed from seeing. Is a number of things, but I think that the key thing is seeing the massive amounts of potential within academia and architects that are innovating in academia, creating these amazing digital fabrication techniques that push architecture beyond its limits in the lab, but so little of it is out in industry. I had some experience working at Oricon, there's some experience working at Arup, and there's a number of frustrations there as well, that colleagues want to implement this stuff, that they want to see this out in the industry, but they can't make it happen because there's just too many people that need to be convinced. There's too much risk commercially. There's just so many barriers, and I came to the revelation that I just sort of have to do it myself. um, um, and that doesn't mean that I'm just doing it by myself. It just means no, we have to start a new venture. We have to build a team. We have to really focus on one particular innovation, make it as efficient and easy for its uptake, in this commercial context, for people within the industry to look past the risk and look at the very high value that it portrays. So in order to get to that point, it's you have a lot of tough weeks.
It takes a lot of effort to kind of go from the research to the commercial side, and I think it's going to be people like yourself who having involved on both sides that are going to be able to push technology such as this forward on the industry and actually that big impact there. No, it's really, really exciting and very, very good kind of I guess advice or lessons learned to anyone that's involved in that sense. I'm pretty sure that at the end of the presentations we'll have a good chat about that.
I think in summary, I guess quite quickly, I would say you have, like, if you want to build a team to do this sort of thing in Melbourne, it's quite a good place to do it because there is a lot of innovation precincts that are popping up everywhere. There's a lot of Fab Lab style places where you can make things and get access to equipment. There's quite technological universities that have equipment that you can access and start to experiment. But when you do those experiments, have a key problem in mind that you're solving. So this project started out by saying, okay, there's a lot of waste in the forming process for materials to create these curves that are really obviously quite structurally efficient and useful. How can we solve that problem? And just be problem focused, build a team, and events like this, get in touch with other people that are in the audience and say hi. And I know it's tough virtually, but go out on a limb and just say hi to people virtually, or look them up on LinkedIn. Don't be shy about that. If they see you stalking them, it doesn't matter. Just say hi and make those connections.
Really good advice, and I think it's one of the things that we're trying to do with this event is to bring people together and to get exposure onto everything that's happening on the industry. Thank you very much for your presentation, Daniel.
Thanks, Andrew.
We'll have a couple of more questions at the end of the session.
Thank you. I'll go grab a beer now, I guess, just real quick.
Make yourself comfortable.
Thank you.
Thank you, Daniel. So we have up and coming our last speaker, which is Alex Walzer. Hello, Alex. Now, Alex is a funny one. He is one of the most curious people that I've ever known, and I think his curiosity has actually taken him through so many interesting projects and to so many places. I remember I met Alex when I was back at RMIT, and since then he's been on and off several countries and several universities and has done such incredible work. He is at the moment a research fellow at RMIT University, and he's working in collaboration with IMCRC and Design Robotics. I'm sure his presentation is not going to be nothing short of interesting. So please, everyone, welcome Alex. And Alex, back to you.
Gracias, Andres, and also thanks for the invite. Yes, I remember our times at RMIT. That was good, and time is running quickly. All right, so let me just bring up my tab. If you could just quickly confirm you can hear me well and uninterrupted, and you can see a screen that says something like construction.
Yes, loud and clear, and you can see the slides.
Fantastic. Okay, so thanks, Andres, for this invite. It's always great to participate, especially in this new virtual kind of platforms. But why not? I mean, even though we are mostly maybe in the same city, but as you showed before, like we're from all around the globe, and we're recording this, so it's great to meet people and friends, old and new. And I'm happy to share a bit of insights and things that I think that are going on. And in this presentation, it's actually less. I can show some work if you want at the end, like I can zoom in a bit, but it's actually a bit like zooming out. And what Dagmar was doing and was Daniel was mentioning is like how everything around us is actually changing, and how we as designers and architects can change the world eventually all together. So my background, I'm by training, I'm an architect, but I also stumbled into maker spaces and fab labs and hacker things, and these two things somehow for some years I didn't put them together, but at some point I just threw these things together, and I stumbled into this field of robotic fabrication and digitalization, or however you might frame that. So I've spent now like almost 6 years in this field. I'm kind of mostly working at universities, but also as a consultant with kind of startups and so forth. So I think just shortly for this presentation, it's going to be, I think, a short one. And I'm just going to outline this kind of the bigger picture, this kind of zoomed out view that I think I can see right now. And I also want to touch bases on the history of robotics, or the kind of the origin of this, because this is nothing new, and we are not, you know, we didn't invent this right now. It's kind of it's the second time we're doing this. So I'll then go to a bit of state of the art and show you some work that is happening around us, and also like a bit of an outlook where I do see things are going, and many of these topics have been raised already. Like I'm showing you stuff that has been shown before, I think, but I'm happy to do so. So I think in the context, if you zoom out at kind of what we do as a global population is, and what we will witness in our lifetime, most likely, is that the global population is going to increase a lot, and so probably at the end of the century we will have double the amount of people on this planet. So if you think, we've heard this, we've seen these statistics, but if you think about it, it's like everything we consume, everything we do, everything we eat, the way we use transport, everything has to change, and everything needs to increase in productivity and efficiency to actually meet the demand. So when you look at productivity across several sectors, eventually most of these sectors, they also kind of, you know, they increased in productivity over the last decades or something, let's say like since mid of the last century. Because, you know, we have to produce food, we need to build cars or products like our phones and so forth. They're highly efficiently made, right? Because all these industries, and manufacturing is maybe the one I'm talking about here, they are highly automated and they're highly digitized for a long time. If you actually go back a bit in time, you can see that this digitalization and industry 3, 4, 5, wherever we are right now, or wherever we might see ourselves in the near future, this has always been a very, very big change to how we live and work and so forth. So if you go back 200 years, maybe, the mechanization and the first industrial revolution, you know, this basically, the steam engine gave power to making looms for like fabrics and textiles, but also enabled us to invent trains and to discover new places and grow cities, and, you know, the concept of time and so forth. Everything was changed. Maybe 100 years later, invention of electricity then I mean, changed everything. You could all of a sudden read a book at night. You could, at the push of a button, you could have light on demand. It sounds very absurd today, but this is, I think, must have been like a crazy revolution back then. And this also, you know, people didn't wait long to then invent phones and these kind of things. I think these must have been crazy hackers back then to like take these new technologies and within a few years construct something that where even the category didn't exist back then. Within the last century, of course, we've seen a lot of you know, like automation rise, and of course computer becoming smaller and more affordable, and electronics becoming omnipresent in every aspect. I think I can see now 5 computers if I just look in front of myself. Today we talk about a lot of Internet of Things and networked communication protocols, and basically look at how the systems talk to each other and how they communicate, transfer, and store data. And this enables us to do this webinar as well, right? This is quite interesting. However, like again, if you zoom into construction, this is an image I found from I think 50 or 60 years ago. Kind of the construction, yeah, the kind of the problem statement didn't really change, because we need to build, right? We need to make, I don't know, like streets and buildings to inhabit and so forth, and make sure that this of course continues. But if you look at how construction works today, and in my case, this is now like looking at reinforcement construct, basically we're still using the same tools, we're still using the same materials and the same processes, and that's crazy, because like as if nothing had changed in 60 years time or more. And I think that the underlying project is not the underlying problem is not so much the kind of on-site, then it's too late. Like you can, for sure, you can do some stuff on-site, but I think the entire planning structure of how architectural projects are being rolled out for some reason or another, they are very, Daniel mentioned it before, maybe it has to be simple and safe, but I think it's very inefficient. And like the way how we now do 3D models, and then somebody makes a 2D drawing from that then needs to, like from a company, from a contractor, be redone because they have different colors, or they use different hatches or something like this, and then somebody can't read it, or, you know, mistakes are being made, you have to check it on site, things are moving, they're unprecise, we have high tolerances, and eventually, after many loops and many kind of feedbacks of measurements or photos and fights and lawsuits and budget overruns, and also overruns in kind of time budget, then we fabricate one prototype and we move on to the next one, and we start all over again, kind of, right? This is now in a simplified way, but each building, each project is somewhat unique. It's beautiful, but it's very stupid. I think it's very inefficient. And I would argue that mostly this kind of the digital planning, the BIM kind of frontier is mostly focused on this, on the left side of like architecture and planning side of things. Maybe of course it has contractors involved and companies, but basically the construction is still done by hand. I think that's the point I want to make here. If you then compare this to manufacturing, in this case automotive, and I think Andres was showing in the intro some images as well. This is an image the kind of the black and white image before looks a bit older, but it's been from the same decade. Like this kind of systems have been introduced in manufacturing like 50, 60 years ago, and this I think worked or happened naturally because the way how cars are being produced or how products are being manufactured, they like the idea of the concept of you know, like a floor plan production, manufacturing line, this kind of concepts by Henry Ford. This was like 100 years ago. So it was then kind of quite easy already to then implement mechanical units to this kind of production. And of course, today we see this in kind of high quality products in airplanes, for example, that they are constructed by multiple machines. Sometimes these are actually like dark factories. Maybe you're aware of this. So I think for phones or for some products, basically there's a factory that is kind of dark, and only the raw materials go in, and then at the end the product comes out. There's no human involved anymore. And this, of course, underlies a very different planning procedure as well. It's not like how we do it in architecture, where we do like a drawing and maybe my perspective is wrong and now the building is wrong, and these kind of things. That the system that manufacturing and also kind of this concept of lean manufacturing, they are very different from the planning we see in construction industry. And one I want to show you is the Toyota way, or the Toyota production system that was established in the 1980s. And basically this is kind of a more state-of-the-art drawing, but if you think about how a car is being made, or even as a customer, how you interface with that, you can order it online. You know exactly how much it costs. You have a few options. Okay, this is maybe the problem, but you have many models and you can change them, and there's various versions of them. And basically then, these kind of things are being fabricated. Data is already stored somewhere. The machine can be processed. Spare parts are being produced just in time and stored in a lean way. And basically this kind of idea of the Toyota production system gave then actually rise to the concept of lean manufacturing. And if you're interested in some of these kind of theories in the 80s in Japan, I can really recommend Taichi Ono. He's written a lot of books, and there's also, you can find some summaries, of course. So looking at Japan in the 80s is actually a good point, because it would be somewhat unfair to say that we have not tried to apply this kind of robotics and digital processes in the construction context. So in the 1980s, you have to imagine, I also have to imagine that Japan was like the powerhouse, was like a very strong economy. And they needed, like, I think they had some demands to fulfill, of course, and they also had the means to use technology for anything, including construction. So they were back then developing like machines, like remote controlled concrete grinding machines, or mobile robots that spray. I think this application is like fire, is an application of a foam for fire safety for steel structures. And this is crazy. This would be today considered high tech, but this was already in the 1980s, right? They had different machines. Like these companies were doing facade inspections, and I think even cleaning of facades. And eventually they even came up with concepts of machines that are larger than the building, and they're sitting on the construction site, and they are like a gantry system and whatnot. They're assembling the building and they're growing with the building. And there's even some kind of concepts and systems from back then that they were even able to deconstruct the building without any noise or dust. They were just like a Lego, just put it together and take it apart. Kind of very lean, no waste, but usually quite big machineries. And this kind of systems, or this kind of prefab idea or modularization of construction, it has of course limitations, but it's a very efficient way to go forward, I think. And we can still see these kind of ideas being applied today with like entire flat pack houses or modules that are being lifted on site, very efficient. If you want to know more about this topic, I can pinpoint to Thomas Bock, who is a professor in Munich, and he was involved in this kind of developments of these machines back in the 80s. It's a very fascinating work, and very how do you call it? Like, it's very state of the art even for today. But one might argue, or I'm just wondering, like, why these things back then didn't work, and I assume that I think it has to do with the fact that these machines are the initial investment is very high to come up with these systems that then eventually don't allow you to be flexible. There were some other macroeconomic issues in Japan after the 80s, but I think the main critique here is that it's difficult to come up with very expensive systems that are not flexible. So what we can see today in the last, let's say 15 years or so, is a kind of a second wave of digital fabrication around the globe. So, for example, groups in ETH Zurich or TU Vienna and so forth, they basically they embrace the idea of having a comparatively cheap machine. Like in this case, for example, this robotic arm costs the price of a product it would fabricate, like a car or something. It's more or less the kind of the level of cost associated with this. And and then you can basically use it to make, instead of a car and being repetitive all the time, you can make also things that are not repetitive, that might be efficient or beautiful or whatnot. And as Dagmar was mentioning before, of course, there were like these kind of clusters were popping up 15 years ago or so, or the last decade as well. And also like new networks were established, like the Robots in Architecture network. So, these are like biannual meetings where people share their research, and you come together, you meet, you exchange, and you grow. And this is crazy. Like this 2012, I think, was the first one in Vienna. And it just grew in a few instances to something very substantial. And of course, and all these kind of these researcher groups that are part of this bigger network, they re-establish themselves as well. So, for example, the National Center for Competence in Research in Digital Fabrication, also at ETH, they are looking at this kind of new processes for on-site, off-site, different approaches to building stuff, but mainly always focused in basically enabling bespoke processes for the building and construction industry. And as a demonstrator, I think that's also what Daniel was mentioning before. What was brought up before is that it has to leave the lab, like nothing that you can do. I mean, it's sometimes nice to do stuff at the lab at uni, but in the real world, there are very different constraints, and sometimes it's very important to bring out this kind of demonstrator project. And I was involved in this particular one. It is a experimental building where industry partners and the NCCR and kind of associated groups together developed a unit, like a house actually, for people to live in, that are only being built or mainly being built by digital processes, like a mobile robot building a reinforcement mesh, that I was on this project, or 3D printed formwork for concrete construction. And then also like this kind of, you've seen some pictures before as well, very complex models where timber units were assembled together and then lifted to the construction site, put together, wrapped in a high-tech facade using aerogel. And also there are the facade mullions. You can see them they're very kind of filigree. They are being slip formed by a movable slip casting process. And today, or this last year, I think these groups were established, but also other universities, of course, now reach out and collaborate with university, and they look at how the kind of construction work or construction sector will change and how this will affect the way we design, the kind of materials and processes we are using, and also to understand where this discussion is going next, because it is more and more involving industry partners. So I'll talk quickly for the ones that are still awake about the project I'm currently involved in, which is called the Design Robotics CRC, and it's basically funded by it's a government-funded program here in Australia, and we collaborate with small and medium enterprises and universities. I'm based at RMIT in Melbourne, but I'm also working with QUT University in Brisbane. And basically here the idea is that, again, you need to involve these industry partners, and they need to kind of, in a way, understand what would be possible if they embrace these new technologies and how it would change their, like put them at the cutting edge of technology and give them an advantage on the market globally and of course domestically. And so here the idea is that you have like more advanced vision systems and user interfaces, because otherwise it's very difficult to use these processes. They only work in a lab environment almost. So as part of this, or the core of my work for this for the IMCRC at RMIT is basically to design these interfaces that you can basically take, in this case mostly formative and additive processes like robotic welding and sheet forming, and you can interface and you can simulate, and you have basically this digital twin that you can then control and make parts. So one project, for example, let's see if this plays. It's basically looking at how this is like a tailored process for robotic welding, but it's actually called wire arc additive manufacturing. So imagine, everybody knows like a welding gun, right? Like a MIG gun where the wire is fed in, and then you melt a pool and you join metal plates. But if you actually stack these layers on top of each other, you can 3D print with metals, and you can chug almost any material in this wire feeder, because the process actually doesn't really care, because metal at some temperature will melt. So you can melt aluminiums and brass and so many materials, and it's shielded by gas, so it doesn't corrode, and so forth. And basically, I'm developing these workflows where you just throw in your design file, and you get all the stats. You know exactly like how long it takes. You know how much it weighs. You can do all the calculations about time and efficiency, and in the end, you get your result. And then the other project we were looking at is incremental sheet forming. That is a very, I think, elegant process where basically the robot pushes with or any system in that regard, could be a gantry as well, pushes against, with the tip that is not moving, pushes against a sheet metal, and basically by incrementally doing so, it basically deep draws a form or a shape from a 2D sheet. So that's a very cost-efficient alternative to maybe other processes that would require the making of a die or a mold or something like this. Okay, I'll wind up. I think currently construction, unfortunately, depends, of course, where you are on the globe, is mostly, I would assume, I would argue, still a very manual process, mostly manual. Of course, we have now this kind of total stations, and we can measure everything, and maybe we can take pictures or do some photogrammetry with some drones. But I think we're not yet out of this kind of range in construction. And maybe in the far future, we will see some more interactive machines or even intelligent machines. Maybe there's nobody on site, and maybe the work that is done on site is being reduced to the labor that necessarily needs to be done on site. But the kind of the heavy lifting and the dangerous jobs and the unpleasant jobs, they will probably, I guess, they will be done, if they have to be done on site, they will be done by machines. I think one point we can discuss also later in the kind of in the panel is about education and how, I think this was raised, Andres was raising this point with Dagmar before, for the ones that were not in yet, is basically how do we educate this, like the next generation, right? Because everybody nowadays is really fit with programming and using a computer, and not afraid of learning how electronics are working and so forth. So, and in fact, we actually see a lot of these kind of new programs. They are not necessarily architecture only, but they're kind of reaching out, and they're also not engineering only. They are somewhat a nucleus between all the different fields, because you experiment with materials and processes and sensing and vision, and all these different things come together and then being mostly deployed in a creative way. And so there are a few programs out there in Germany, Switzerland. I've also read about recently one at, I think, at UTS, that is a master program only for Industry 4.0 in manufacturing. It's very interesting. I think it's starting kind of this year. We will see in the future kind of material companies or construction companies much more like doing this kind of internal innovation projects, where they basically further integrate vertically within their supply chain, and they will be not just delivering materials, but they will deliver finished products, which changes completely the value proposition of some companies and these kind of products. What we also can see already, and we will see in the future, is not just one industry doing their development, but basically industry partners working together. So this is, for example, a project or a product, a modular prefab housing product that you can buy in Sweden. And who would have thought that this was developed by IKEA and by Skanska? And I mean, everybody knows IKEA, I guess, but Skanska is like one of the biggest construction or developer companies in the world. So it's very interesting to see these synergies and these kind of companies co-create together. What we can also see, of course, and maybe this is what where maybe Daniel's project also comes in, is like university spin-offs and kind of ideas that are basically forged within university, but they need to leave at some point. They need to go out and they need to maybe struggle, but they will get traction. And if this is eventually being confirmed by the way that now, of course, also the entire venture capital and startup funding kind of landscape is opening up, and we can see big investments. And there just because also there are so many different sectors where actually innovation can be played or innovation can be found in construction. There are so many different topics. It's not just only about the work on site, but there's so many things that can be improved. And we can see already like the first unicorns being formed. Maybe some of you might be aware of a Californian startup called Catera that works in timber construction and just integrates vertically, horizontally across the supply chain, and just it's basically the Google, maybe let's call it, for timber construction in the future. And they have already raised more than 1 billion in funding, and I think they're now evaluated at 4 or 5 billion. It's crazy. It's very large, massive factories. All right, so time is running out. That was basically my small presentation. And look, if you have further questions, reach out to me. I'm on LinkedIn, Facebook. You'll find me. You can scan the code. It should bring you to my LinkedIn profile, and you can also check out my my webpage. Thanks, and back to Andres.
Thank you very much, Alex. There's just so much to discuss about this topic, I think, and just finishing your presentation, so many things that emerge, and there's quite a few questions or comments already coming through the chat. Please keep them coming. I do have some questions myself, but I'll keep those on hold. And someone actually asked, it's Kai, Alex, which delivery and business models do you think can best support or deploy lean construction processes, for example, Alliance in Australia and IPD?
Good question. I think, at this stage, there's sometimes, or mostly, many times, there's like you can have a very good business model and you can streamline your kind of channels, but you need to. I think the biggest hurdle, what I see today, is not the feasibility or the lack of understanding of what you can do, like what you can achieve technically, but also financially, or how your business plan is set up. But the problem is like the industry. I think there are they're still playing by the old rules, and I think there we need to find a way to kind of go in much deeper, because we're still kind of swimming on the surface, and that's where I think that's where the problem lies in deploying this kind of lean processes to construction. It has to do also, I think, with maybe some issues that have been raised before about quality control. Like our buildings, we don't really know how they behave and so forth. And if you look at, for example, automotive, every car has their like safety ratings, and we know them. We can do crash tests on them and so forth. It's quite advanced as a product, I think. But pick me up maybe later. That's a long question to answer, I think.
Yeah, it's definitely a very interesting topic. It's hard to answer. There's so many things happening. Thanks, Alex, for your presentation. It was great to see so much, like a very clear transition on how the technology has been moving forward. And I really appreciate that you went quite global in the way that this technology is being utilized, and kind of the inception of all these things on several areas, and very valuable resources that were shared as well. I think this will be the end of the presentations, and I would like to open up the roundtable discussions now. So I would invite everyone that's willing to turn their cameras on to do so, to just kind of make it a little bit more human in that sense. It's kind of free for all now. If anyone has any questions, please just raise your hands. Feel free to unmute yourselves and ask a question, otherwise you can drop it in the chat. And I think I would like to start with the roundtable discussion with one question that I think the three of you can just jump into it quite clearly, I think, with a lot of opinions. There's a lot of different examples of how research varies from country to country. And I think one of the examples I would like to reference is the one that Alex just showed, which is that 3D printed house on Zurich. One of the questions that I have is, what are the main things that any of you think is stopping a project like that, for example, to happen in Australia? Or what are the main differences that you have spotted between working at different countries that actually makes a big difference in pushing this technology forward from academic research to a commercial application? And it's an open floor.
Maybe I'll just give my 2 cents. Wow, the chat is going crazy. Okay, so I didn't see the chat before when I was on full screen. Sorry for not being responsive there, but I just followed up. Yeah, so Andres, thanks for your question. I think that this topic is much larger than any institution or any kind of company or idea. I think what it needs and why it was successful with the DFAB house is because many people, they kind of funneled their forces and they worked together on something much larger, and that something that will last and hopefully like kick off other discussions somewhere else, and basically to get the ball rolling. And this building is still standing. It fulfills building code. So these were some kind of challenges, I think, that were underlying. But if you have enough brains and given also actually enough resources and time, you can actually make this happen. So it's not a question, I think, whether like this should happen or whether it works or not. But basically, once people are allowed to prove that it works, you will be surprised how many things will change in the near future and how many of these kind of pilot projects we will see.
I think yes. I mean, it's such a broad topic. It's very nuanced in the way that it depends on a lot of different factors. It's not just one thing. So the discussion in that sense, I guess, could go forever. I was just reading in the chat now. There's Will Jokes shared and I'm sorry if I just butchered your last name, Will. Shared a really interesting link. It's talking, the first title that I read there says Industrialized Construction, the Rebound from COVID-19. I think this is a very easily present topic, and I think, Dagmar, I don't know if you have any thoughts on how do you think the current situation and what we've been through this pandemic in terms of a shortage of products and the stop of production chains to some level. How do you think that's going to impact on the academic research that's been undertaken? And what do you think is going to be the focus or the shift in that area?
Yeah.
So, but if
I could. Sorry. Just want to jump in.
Go ahead.
I think we've had a lot of struggles. Trying to research involving hardware. You kind of have to be on campus or where the technology is, where the hardware is, and especially here in Melbourne, at least, it's been very restrictive in that respect. And from a personal angle, because I have this other entity, I have the ability to have a worker's permit and still operate as a sole operator in my business, in my factory. And what I've been doing is being able to facilitate those other research streams that I get involved in through the factory. So we just find a way and adapt and continue. It hasn't been so easy, but you can't have as many people involved very closely and that sort of thing to get involved with the hardware. It's been difficult, trying to guide research assistants remotely for sort of virtual tasks, but you still find a way, right? This isn't going to last forever. We find more ways to work more efficiently using this digital technology, getting more used to working virtually like this and not having that travel burden. You just work through it the best you can, and I think by the time we're on the other side of it, we're going to be working much more effectively and developing things much more effectively. But I think that maybe there needs to be a bit more communication and collaboration around, what facilities can we actually access now to continue that sort of research in the hardware space. And maybe this is a good forum to share some of those thoughts about how that might happen.
Yes, I mean, obviously collaboration and communications have been impacted so much, and that's going to be one of those subjects that are going to definitely have a massive impact. Dagmar, what are your thoughts on the subject?
Look, I'm loving the question because it's again, I mean, everybody's talking about COVID, pandemic, etc. So if I want to take it from a sort of slightly cynical standpoint, I can say we're actually doing less face-to-face teaching, which basically means our digital fabrication labs and also as a consequence of that, our robotic research lab has less demand and less population in it. So I could basically say it's a great time for research, simply because we are sort of underpopulated by the demands of 400 students running through the usual faculty setting. So why don't we kick off and get it going? So that's sort of on the teaching agenda. But then of course on the other side, and of course I can always run 4 people or 10 people in the robotics lab, no trouble. Even with social distancing, so that should not be something that takes us out of the action in that arena. I think what concerns me more is the current climate of sponsored research or government-funded research. So within ARC grant applications that are landing in architecture for roughly like 1% of projects being funded. I don't think, even with robotic fabrication, which is sort of like the whole thing in a nutshell, we're not getting closer. We're not getting close funding with COVID, and that's also very clear. And I think, I think the clearer we are about that, the better, because I think, quite frankly, the future for us to go forward is very clearly with industry relationships. And that's where we should go, because those are the people who do have stakeholders' interest in that, who do have the knowledge that we need in order to rethink existing processes through robotic technology. Because we tend to, we can't reinvent the wheel the whole time, right? And we shouldn't. So we need to learn from industry expertise and then be able to transport that expertise towards what we can offer in terms of computational design and then robotic fabrication. So I think we are looking at a very rosy time if we can get hold of, or if we can establish industry partnerships. So that would be one avenue. I think the other avenue is Europe. There's a lot of people who are working together. So the whole Scandinavian network is working together. I mean, ETH, of course, they're not so much working together with a lot of people, but they don't need to. But I think Sigrid and Johannes have done some fabulous interactions these days with the RWTH. And thanks for Alex for pointing that out. So I think why don't we just, sort of push this forward in terms of an Australian network and really start exchanging some protocols, exchanging some pedagogical frameworks. I mean, we really do have it all already. It's just a matter of how good we can start to synchronize with each other.
Mm-hmm. Yes, that's a good advice, and it's really interesting how you mentioned the funding mechanisms and the ARC grants. I've personally found, looking at them, that it's kind of quite clear the area in which something such as robotic automation for manufacturing processes sort of fits within the overall priorities of the governmental research funding. But when it comes to architectural robotics or something more towards the design side, I found it to be a little bit of a gray area and not so well, like not so clear in terms of how much funding actually goes into that area. And even looking at what grants are available, it becomes a little bit trickier in that sense as well. And it kind of makes it evident that the relationship with industry partners is obviously very valuable and a very good way to move forward. I guess one of the questions that I would have is, there are several stages around what comes as what's understood as industry. You have the initial stages of projects and you have the last stages of projects, and it's broken down into something such as design practitioners all the way to construction operators. I guess one of the questions that I'm trying to get at is, where do you see most of the need or most of the inquiries from industry are coming from in terms of that process? And what kind of companies, I guess, are starting to be much like more interested in a funding model or a partnership in that sense?
Mm-hmm. Yeah, I can tackle this one. I think that you can look at all of the segments. I think you look at precasters. They're very concerned with capital expenditure. They don't have enough to transition into robotics, so they need to be incentivized. If you look at developers, they see a lot of value in innovative techniques if they're an innovative developer. And if they see the value in that in terms of differentiation, then they are quite a key player economically in this space, because they're the ones that are paying the bills. And then if you look at engineers and architects, well, they really want to innovate, but they don't necessarily have permission from the developer or the builder, and the builder takes charge once that contract flips over to the builder. So the builder is also a key in order to transition to these robotic techniques, and they actually really want it. They just need to be spoken to really early on a project, and yeah. Yeah, so the builders and the developers, I'd say, are the real touch points that we really want to speak more to, incentivize, make it easy for them to uptake this technology. And then I think the engineers and the architects, even though they really want to, they don't have the power in the contractual relationships to actually push these, except for specific really big projects that are driving that sort of agenda. So yeah, that's how I see the industry at the moment. From the government perspective as well, there's quite a lot of drive in terms of looking at new programs in low carbon incentives in the building construction industry. New South Wales is coming up with new programs in that space. State government in Victoria are looking at manufacturing and incentivizing manufacturing in some way. And there's all these organizations from the political sphere that are trying to push things from a financial standpoint, but not really understanding the complexities of the construction industry that need to be solved, and that link between them, trying to bridge that educational gap and create focus around influencing developers and builders to take on this technology or take on these new processes, so that we can feed into their value chains and their power within the relationship economically, so that they can uptake this technology.
I think that's a very good leadway onto actually one of the questions, which speaks about more broadly other industries as well and how those ones kind of relate to what we do, which comes from Angel Linares. So one of the questions there is there's obviously a lot of knowledge, accumulated knowledge that exists already outside the industry as well. Because this technology is not particularly new in other industries. I think it's a very good way of closing out the conversation, unless anyone has more questions. Which other technologies have you guys observed? And this is a question for anyone that wants to jump in. Which other technologies have you observed that have been impacting or have already impacted other industries that you might think, actually, this is going to have a tremendous impact, or this is the one that should be adopted soon on our industry?
It's from outside of the building construction industry and coming in. Is that what you mean?
Yes, exactly.
I think I'm gonna be devil's advocate on that one, because I think there's a lot of technology that's been shoehorned into the building construction industry that doesn't fit already. So there's a lot of work being done to use like aerospace grade software or processes that are too precise for the building industry and need to be simplified in terms of software, but also from the manufacturing and automotive industry, manufacturing industry, the robotic systems are too complex. We need to simplify them and make them fit for purpose for robotics. For the construction industry to build those components much more efficiently, say for instance the software that drives the robotic systems that are integrated on Industry 4.0 platforms and that sort of thing. Siemens software is so complex and overly complex. It's so difficult to navigate and integrate these sort of systems that are required for construction that need to be simple, because the high skilled workforce just isn't there. There's a lot of drive from the younger generation to get involved with this technology, but there's not the opportunities in Australia yet to really actually get involved within industry with this technology. So there's still this knowledge gap that needs to be bridged, and I think just from personal observation through this journey, it really just needs to be simplified. And that doesn't mean that it's a dumb system. It means that it's just easy for someone to understand how to operate the thing and how to make stuff with it. There can't be this huge barrier to entry like with KUKA and ABB. Like they don't have like very accessible training for people to really access the advantages of the machines. The cost of those systems are quite expensive for precasters. They can't can't afford them. Yeah, I'm talking about the concrete industry, but others. But there's a lot of shoehorning happening. I think that we need to really think about what problems do we really need to solve in the building construction industry, focus on those, and then get some really clever minds targeting those specific problems from mechatronics, from engineering, and we kind of just have to build from the ground up. And it's a perfect time to do that, because the technology that's available to build those systems are actually really cost effective and really accessible. You can learn how to program things with Arduino online. That's how I learned. You can access all of this stuff.
Daniel, I think
Yeah.
point, which is the point of software. Dagmar, I know you want to say something about
You know me a little bit, but you already know me because I've sort of been scratching here with my heels. No, I think thanks for mentioning all these points, because I think what we need to ask is these fundamental questions: what can we actually do better by doing it with a robot? So why do we use the robot if we can use any other, like a traditional labor or traditional machinery, etc. So I think there's 2 points to that, which I think are equally attractive. One point is the idea of the big data scape in relationship to Industry 4.0 and the idea of robotics integrated within that system. So just as an illustration, in Scandinavia, you have a sort of larger scope of forestry. So you have the possibility to have the forest, you scan the forest, you harvest one particular tree, you cut the tree down robotically or otherwise into a particular, so it becomes a resource material, and then you feed it back into sort of the construction demand, or rather the pallet or the resource archive that is existing there. So I think just looking at robotic fabrication as an isolated moment is probably not going to get as far, because that's always only going to be just one point of the equation. So that's one thing. I think the other thing that I wanted to bring up is, I mean, we talk about COVID, but really what we talk about is climate change. And I'm always interested in this sort of triangulation, which is not really, I'm just doing that in research because that's easier accessible for me, because that's my playground. But the idea is really, so in a climate of, limited resources, or in a climate of, 200 kilometers, and you need to get these materials, how does a robotic fabrication contribute to that equation? So for example, can we print with local materials, clay, like if you use your concrete works, which are absolutely fabulous, can you use local products in order to deal with the robot? I mean, equally, stereotomy, or sort of stone carving from existing structures. So, and that all relates back to patience and precision that is offered by the robot. So it's like, I'd be really careful to, sort of not continue with a conversation where we can say, okay, let's help the construction industry, or let's replace humans, but really to go more towards that direction. What's using that fantastically resilient instrument? What can we do in the future that is also, fulfilling our responsibilities as human beings to not fuck up this world within the next 50 years for everybody who comes after us?
Oh, that's such an interesting point. And actually, I think it's a perfect point to close out the session. And I know, Alex, I'd like to give the floor to you for some closing remarks, because I know you're a big advocate on this. What are your thoughts?
Mm-hmm.
Thanks, Andres. Yeah, so there's a few things. I think that, I mean, I don't want to downplay the coronavirus thing, that this devastating, it's nasty. But I think, kind of apart from a health crisis and economic impact and so forth, but I think what it really showcases and where it really hits us in the face is basically, it shows us how our supply chains are dependent on centralized manufacturing, like outsourced, offshored manufacturing clusters. And we lost kind of control, being it Europe, Australia, or wherever. Actually, we lost kind of the idea of making things locally. And I was a student of Neil Gershenfield, and he came up with this idea of kind of distributed manufacturing, or the kind of the fab lab, and the idea of how to make almost anything. And I think now, through this kind of crisis, through the lens of the crisis, it really makes a lot of sense to actually to push to more like local and distributed manufacturing hubs. So in concrete construction, there are many precast facilities and factories. So usually the concrete truck doesn't drive long in an hour. So if you look at the map of how kind of concrete construction is being managed, and how the material is being ordered and processed and paid for and so forth, I think this is maybe an insight of how this could work for all other products in construction as well. But yes, sustainability needs to be the most important like resourcefulness, I call it, maybe needs to be the most important kind of objective, and we use robotic and digital processes to guide us there. I think that's important. It's not only because robots are cool, but I think the most important part is it makes things more efficient for us and for the planet. We use less resources, we are faster, we can build better, we can make housing more affordable, and I think that's a goal that the entire world should strive for. That's just my 10 cents. And I think that COVID itself is the biggest accelerator for technology that we might witness in our lifetime. And if we embrace it, I think it's fabulous. It's great. So I've been remotely collaborating with universities in Wollongong and Brisbane, and this Arm Hub and QT and so forth. And no problem. It needs a bit of like the gears need to grind and they need to work. But after all, I think it's very promising. Of course, we are dependent on hardware. But again, once we have our hubs and local distributed manufacturing in place, 3D printers at home, I think we're all good and all set. So I think that's where the model of construction the future will go towards, I think.
Yeah, well, that's actually I mean, perfect way to close the session, I think. it's the general. I'm just conscious. I don't want to. Gosh, it's just such a good discussion, and I really want to keep going. I'm happy to keep extending it if you guys want. And you're also just conscious that you've already been quite generous. It's been a long session. I think there's a lot to take out of this session. It is being recorded, so you can rewatch it at any time, and you've got everyone's contact details. If you don't, please feel free to reach out to me, and I can connect you to any of the speakers. Otherwise, you can find them directly on LinkedIn or any of their other platforms. Thank you very much, everyone. This has actually been amazing, and I think. Dagmar, if I may, I would like to quote you. Please, let's just not mess up this world. Let's use technology on a conscious way. And as Alex said, robots are not cruel. They are our friends. We can use them wisely, and we can actually make very good progress. And quoting Dan as well. Let's just persevere, keep moving forward. Push for an idea. I mean, very, very great things to take out of this session. Thank you so much to all the speakers. Thank you so much to all the organizers. And if anyone wants to hang around for a virtual drink, I can put the jazz music back on if you like. Otherwise, let's go. Thank you so much.
Thank you.